Okay, I think we'll get started. Yeah. So good afternoon, everybody. Thanks for taking your time to attend this session. Hope you're having a good day at PGConf India. My name is Shriram, and I'm a part of the product team at Microsoft working on Azure database for PostgreSQL. And today we are going to talk about our flagship offering, which is the flexible server. Okay. And before I get started, can I just get a show of hands as to how many people are familiar or kind of used flexible server here? Great, great. So yeah, I think the two key takeaways I would say from this session would be like, what are the important things that existing customers can take away who are using the product, and also for folks who are listening to this for the first time, hearing it for the first time, what are the key resources that you can use to get started immediately. And with that said, let's get started. Okay, so flexible server is designed to meet both enterprise and developer needs. And these are the two foundational pillars on which we have even built this managed offering. And when it comes to enterprise, the requirements are quite simple, right? Like, hey, I need my database to be available all the time. And if I don't want any unplanned downtimes, any server restarts, and like my business needs to continue my business needs to be continued all the time. And if there are any unplanned outages at your end, try to recover my database with minimum data loss and minimum downtime, right? So to address those features, we have come up with like the high availability concept as well as the disaster recovery. And when I talk about HA, it's like we spin up another standby server for your primary. And that particular standby server constantly replicates the data from your primary to the standby. And this is synchronous replication, which means that any data or any transactions that commits to your primary has to be committed to the disk of the secondary before an ACK is sent back to your application saying that the data is committed. So by doing that, what is going to happen is at any point in time, the data on the primary and the standby is going to be at exact sync. So if something goes wrong with your primary server, we can promote your standby as a new primary server with zero data loss. And that's the USP of high availability. So you won't encounter any data loss. And we do support two different setups for high availability and flexible server. One is the same zone HA, which means that your standby is going to be in the same data center. And like if something goes wrong, if there is a nodal failure, let's say there is only a problem with your server, we can automatically detect it and promote the standby to be the new primary. And we also have the zone redundant HA, which means that your standby is going to be in a different data center, different availability zone altogether. And let's say in case of a AZ failure, which means that the entire data center is down, we can still bring up the standby from the other data center and make it as a primary. And here this is in place, which means that you don't need to change the connection strings. You're still going to retain the same server name and other things. Okay, and in terms of disaster recovery, we do support the concept of replicas. So one primary can support up till 5 different replicas, both same zone and cross-region replicas is there. And we also do have the concept of geo-redundant backups, which means that any data that's actually writing to your primary, we copy the data to a storage account in a different region altogether. And let's say if in a very unusual case where an entire Azure region is down, you can still bring up your server with the data using the geo-redundant backups with minimal data loss and minimal downtime, right? So this is how we basically address the high availability and disaster needs. And then we have another important pillar that we want to delve deep into today's talk, which is scalability. So think of it as like you're already running a workload on flexible server. What are the options that you have to scale in terms of compute, in terms of size, in terms of IOPS? We'll delve deep into this. And also in terms of security, what are the innovation that we bring into the flexible server to make sure that your data is at most secure by running it on flexible server? These are the two pillars that I want to delve deep as we go into the talk. And on the right hand side, you have the developers, right? Like Postgres is a database for developer. And we have built multiple Postgres connectors, intuitive SDKs. We're also committing to open source extensions like Citus, PGCopyDB. These are like prominent extensions that are used by multiple folks in order to do migration or to horizontally scale out, etc. And on top of that, we do have a lot of good utility services within Azure that can help you. And we are trying to see what is the best way when you're a customer in flexible server, how you can easily integrate with those services. And we will delve deep into this topic as well. So these are the 3 things that I would want to delve deep as we go into our talk. All right, so we currently, as of today, we have 60 plus Azure regions that supports open source products, including Postgres. And there is actually a constant need to come up with more regions. So in case if you want to start with flexible server, we are pretty sure that we'll be having a data center to support your data to meet your regulatory and compliance needs. And all major versions that is released by the Postgres community is made available in flexible server within a few days. And I really wish I had a chart to show what progress we made over the multiple releases. Like when PG15 released, actually took more than a month for us to make it available in flexible server. And like when it came to PG16, it took almost around like close to a month. And PG17, we now made it available in Flex within a week. And the goal is to actually make it available even faster, right? And we have process in place, and we are working on it to make it available to the customers as soon as possible. Minor version upgrades are done automatically through scheduled maintenance. And we also have a very cool feature which is called in-place upgrade or major version upgrade, where you can actually, once you're in Flex server running a particular Postgres version, you can move to a higher version without a data migration with just a downtime of a few minutes. Right? So for example, you can run on PG13, and let's say you want to move to PG17, you can do it using this one-click operation called major version upgrade, and it will do an in-place upgrade. You'll still be using the same host name. Nothing changes. It's just the metadata, and just like an upgrade happens. Very cool when compared to doing another data migration to another server with a different host name altogether. Okay, so as I said, like we'll be delving deep into scalability. So before going into the depths of scalability, I'll just want to give a context as to what we offer in terms of the different SKUs in flexible server, and then like we'll take it from there. So we offer three different types of SKUs. One is called the memory optimized, and this is the SKU for high I/O workloads. This is where like the applications cannot afford a high disk latency, and then like this is mainly for analytic workloads and high transaction OLTP workloads. So that is mainly for memory optimized SKU. And general purpose is another SKU which offers more balance in terms of the memory to vCore ratio. Majority of the OLTP transactions fits well within this SKU. And finally, the burstable SKU is something that we want to give customers an easy way to get started without much investment. So this is like if you want to do a POC, or if you want to do some testing, you can get started with burstable. And burstable offers like a baseline performance. And then like if you do like it offers a baseline performance, and as long as the credits are not being utilized, you can accrue the credits and then support a burst of traffic until all the credits are exhausted, and then comes back to the baseline performance. So again, very easy way to get started, and burstable would be the ideal environment to do a POC kind of things. All right, now let's talk about what are the options that we have in terms of scalability. You can scale compute. Compute is completely elastic, which means that you can move up, you can go down, and the USP of this is like if you go ahead and change your compute, the actual downtime to your server is less than 20 seconds. And I have a very cool demo to show that as well. Scaling storage is completely online, which means that you can go and change the size of the disk, and there is going to be no impact to the server. Before, it used to be the case when we change the disk, you have to do a server restart for the changes to kick in, but now we have made it completely online. And now the decoupling of IOPS and size. So we used to follow a model where like you need to provision a higher disk in order to get a higher IOPS. And what ends up happening in most of the cases is like customer provision a disk so high to get the IOPS, which they never end up using. So we kind of decoupled IOPS and storage altogether, and now you can pick a different performance tier for an available disk that you have. And this can be done during the server provisioning, or even after once the server is provisioned, you can go and change the IOPS that you want. And now here is a demo which I'm going to run here. So you can see like I have 3 terminals opened, and on the terminal on the left top, I actually display a command to show what is my current SKU that I'm running. And if you look into it, it's a 2 vCore general purpose SKU, right? And now let's say that I want to go ahead and change it and scale up the SKU from 2 vCore to, let's say, I want to move it to a 4 vCore SKU. Okay? And then I press enter, which means that there is an upgrade operation that's actually happening behind the scenes. And on the right hand side terminal, I'm just running a Python application, and you can see some output that's getting printed. And let's look at what the Python application does in the lower terminal here. So it's actually a very simple piece of code where you actually make a connection to flexible server, and then like it actually prints the current timestamp, and then like there is server IP, and then it tries to print a call. And then it has a retry mechanism also in place, and it tells like if there is a connection problem, it prints it out. Very simple application. And the context here is the upgrade is happening behind the scenes, and the Python is trying to connect to your flexible server, and everything is working good as of now, right? So there is no problem, and if you let it some more time, you can see that the application is complaining, saying that I'm not able to connect to the server. Okay, and let's look at how much duration it is. And if you give it a few more seconds, the app should be able to connect. Like as you see, the connectivity happened, and then the app was able to connect to Flex server. Now, this window is where there was an actual downtime to your server when the upgrade process was happening. And if you compare the timestamps, it's actually started from 8:05:26 seconds to 8:05:49 seconds. And if you subtract the two timestamps, it comes to close to 23 seconds, right? And also the upgrade process completed, and now we can see it's now running a D4 SKU from a D2 SKU. So scaling of compute, yep.
So the wait time differs on how much data is there on the disk, or?
No, it's a near downtime scaling. So irrespective of whatever data that you have, the downtime when you scale up a compute or scale down a compute is going to be 20 seconds.
Is it also irrespective of the DOs, let's say from
Yes.
personal to channel purpose? Still it's
Yes.
Any transaction that was happening during that time, it will be.
Yep, that window of 20-second downtime, those will be lost. Like you will not be able to connect to the server.
So the update will wait if current long-running process is if the transaction is running or currently running.
No, that won't happen, like because there is an upgrade process. So we spin up another VM altogether. We copy the data, and we won't wait for the long-running transactions to complete. But we would expect all the things to complete, and then expect you guys to trigger the upgrade operation.
It's already running, and then I trigger this update.
Yeah.
So
Then it won't wait for that long running to complete, but rather like copy the existing data and then like try to upgrade the SKU. So that is the.
So in that, do you expect the application to
Yes.
handle the
Correct. Exactly. Yep. Okay. Any other questions before I move on? Okay, I'll take that as a no. All right, so we just saw, and yeah. So one concept of scalability is like scaling in place, right? Scaling horizontally if you want to scale the compute, if you want to scale the storage. And the other factor that we want to pitch in here is like to make sure that you get the proper utilization, resource utilization of the existing SKU. So what we have done is like we have added in a couple of really cool features that helps you identify bottlenecks in your current database and helps you to remove it. And one of that feature is called index recommendations. So gone are the days where like you actually have to identify what are the existing indexes that you have, what is the query cost that it's going to create, what is the size it's going to have. Now we have brought in a more automated way for us to tell you like what are the indexes that are actually creating a bottleneck, what are the places that you have to create index in order to most optimize your workload to run in this existing SKU. So this is through index recommendation, and I'll just show you a demo of that. And we are also coming up with server parameter tuning. So you know, like in a managed service, you'll be exposed to so many server parameters, and like by analyzing your workload and queries, we now have the capability to actually tell you what are the server parameters, which one you need to change in order to make the workload more optimal with your existing SKU. And this is something that we'll table it for a later discussion, but I want to show how index recommendations actually work. So now we are in, yes.
just going back for that downtown only.
Yeah.
So why that 20-second gap is there? Like, is the connection for that or?
So yeah, so basically what, yeah.
So basically we are kind of switching, you are going to a different SKU, right? So you're asking from 3 cores or 4 V cores, whatever what you want. So we have to provision a new VM. And like technically, how will you do? Like if you are on a single VM, you shut down the VM and you add the compute and then you restart the VM, and that's the higher downtime. But now with this near zero downtime, we create a nameplate snap, something like a blue wheel, and we just inbuild and just like instead of 2 vCores, we create a VM with 4 vCores. It's a snap. We do some checking and everything is fine. Then we do the swap. So by the time we are doing our work, it's not your downtime. Like your application is running. When you're ready to do the swap, then your downtime starts. And
Yeah. Sure. Any other questions? Yeah.
The index recommendation.
Yep.
Does this mean the indexes, like unused indexes or
Yep.
redundant indexes?
Yep. Yep. We are just going to cover that in this time. Any other questions? Okay. So I'm just going to show you how you can use the index recommendation feature. So you go to the portal and there is an index tuning thing, and then you just turn it on, and by default it is 1 hour, and then you can set the tuning settings and change it to a different time. So in this case 4 hours. So basically what is going to happen is we are going to analyze the last 4 hours of queries that your workload has run, and then like we also have exposed multiple parameters like, hey, what are the parameters that I can set for create index recommendation and drop index. So for example, hey, I have not used an index for let's say 5 days of my running my workload. Now should I take that as a trigger point to say, hey, drop that particular index, right? So we have exposed a bunch of properties there which you can configure, and then based on your configuration we are going to suggest either creating index or dropping index. So I've just gone ahead for this demo with the default settings which are kind of optimal, and now after running or analyzing the workload for the last 4 hours of queries, I was able to get so many index recommendations, and you can basically click on each and every single recommendation here, and it's going to talk about like, okay, what is the table, the schema on which the index needs to be created. It also has a SQL script which you just need to copy, log into your database and go and execute it. And on top of that, it also has an impact assessment which is going to tell you like in its current shape and form what is going to be the size of the index and how much is the query reduction cost is going to come because of creating this index. All this information is available to you, and we also store this particular information. It's not just available in portal, but rather like when you create a server in flexible server, you get a particular database called Azure Sys, which is the system database that we provision, and we persist all this information inside a particular schema in that particular Sys database. So you can use that, you can get that information from there and use it to create index or drop index based on the recommendation. No. We don't directly do that. Like we give the script which you can copy and kind of execute it on the using any tool.
Somebody would do it at the mean time, by the way.
Exactly. Yep. And at least for my workload, like which I just ran it for this demo, I used to have a lot of drop index recommendation used to come because like I just created index, it was not used on my tables. And after actually taking the recommendations and inserting those indexes and dropping those indexes, my average CPU utilization dropped from 70% to around hovering around 18%. That's a significant drop in terms of like proper resource utilization, right? So the takeaway here is like you can use this index recommendation feature and use it on your workload, and you can also give us feedback whether it is like counterintuitive, whether it's like helping in order to utilize the resource properly. So this is regarding proper utilization of your resources when we talk about scalability.
So this index thing,
Yeah.
it recommends only to drop indexes which are not used, or it also recommends to drop indexes which are inefficient?
Inefficient as well. So when you try this feature, right, like you can get a list of parameters, right, like that also talks about inefficient indexes, unused indexes. So what are the things that needs to be met in order to trigger a drop recommendation for index? So you'll be getting all those settings there. Like if you go through it, I think it's pretty intuitive how to use it.
Is this available for all
Yep.
Postgres versions, or is it specific?
Available for all Postgres versions. All right. So the next part of scalability is like understanding the existing limitations that we have in our existing SKUs, right? So currently we run SSD v1 which is like the nomenclature that we use for the disk that we attach with flexible server. And there are some limitations with that. Like one major thing being it can support only a max of 20,000 IOPS, right? And also if you have tried increasing the storage, there is no granular increment. You have to go by multiples of 2. Like for example, you can move from 64 to 128 to 256. There is no granular increment there. And also we support a max storage of around 32 terabyte, right? And when we compare that, like we got a lot of feedback from our customers regarding the IOPS throttling, that being the bottleneck. Now we are trying to address this limitation by introducing one of the best infrastructure that we have in Azure, that is called the premium SSD v2 disks. And if you compare the performance of SSD v2 versus v1, I think it's night and day differences. And I'm just going to walk you through that with a demo as well. So it supports up till 64 terabytes of data, and it can go up till 80,000 IOPS. And the transaction throughput, we are seeing by doing the multiple benchmarking exercise, it can give up till 4.5x times higher throughput and 45% lower latency. Now let me just walk you through the benchmarking exercise that we did for this demo. Yeah.
Does not support a ZRS.
Which one?
V2.
Yeah. So it's actually like we are trying to make sure that there is absolute feature parity with what we have with SSD v2 and v1. Maybe it's coming up in the future, but like definitely the goal is to make sure that all the things that are supported in v1 is supported in v2.
We tried for the SSD V2 and I think it doesn't support the ZRS.
ZRS? Okay. I need to check the exact dates as to when it will be done, but definitely the goal is to have parity between the disks.
By end of the year. And it's in preview and that's
Yeah.
we are doing 100% feature parity between V1 and V2. So by end of the year.
Alright, so let's walk through this demo here. So I have two terminals here, and I'm running PG bench benchmarking. So like it's nothing but like it's going to insert some data, similar data into multiple tables, and I'm running at a scale of 50,000 and client connections, active client connection is 64. Okay, and I'm running this on the right hand side with SSD v2, which is going to have that SSD v2 disks, and I'm going to run the same thing on the left hand side, which is the SSD v1 disk. Okay, and I've already triggered the benchmarking script on the right, and just as it progresses, just look at the transactions per second and latency, right? Here on an average, you can see like I'm getting close to 15,200 transactions per second, and when you compare it with our SSD v1, we are getting close to around 4,200. And compare the latency with what we have with 14 milliseconds compared to 4. And let's wait for this to run a few more seconds, and then we should be having the overall average. And you should easily see that like the transactions throughput is more than 5x, close to 5x with compared to SSD v2 with what we have in SSD v1. So just completed on the SSD v2, and by the way, this is running on the same compute. The only change that we have here is a disk, right? And you can see the transactions per second average comes to 15,344 with a latency average of close to 4 millisecond. And look at the transactions per second here, it's 2,900 and with a latency of like 21 millisecond. So it's blazingly fast SSD v2 when compared to SSD v1. It's currently in preview, and we plan to make it GA by end of the calendar year. Alright, so we talked about scaling in place, we talked about bringing in the best infrastructure that we have currently to flexible server, and finally, what is the option to scale out? How can I distribute my data residing in my flex server across different machines, right? And we introduced this concept called elastic clusters. An elastic cluster gives you like a cluster-wide management operation, all accessible through one particular host name. You have multiple machines which will be accessible through that particular host name, and your data will be distributed across multiple PostgreSQL machines, right? It operates on a shared nothing architecture, so like each machine is going to have a uniform compute, uniform disk. If you support HA, everything will be uniform. There is nothing shared, and this is how the architecture is going to be. Yeah, so every node, as I said, nothing is shared, no resources are being shared, and every node has two things. One is the metadata, and the other one is called the shards. Metadata consists of where is the other data being resided across multiple nodes. It keeps tracks of that using that metadata tables. And shard is nothing but like a unit chunk of data, right? And sharding, we do support two different types of sharding. One is row-based sharding, other one is schema-based. And in row-based sharding means that based on a shard key, the data of your particular table will be distributed across multiple machines, managed through the cluster. And in terms of schema-based sharding, the data of one schema is going to come and sit in one particular node. This might be like a good use case when you have an ISV managing multiple customers' data. You can actually go for Elastic Cluster to manage the data more efficiently. And this also gives me a good segue to introduce Claire's talk tomorrow. So there is going to be a detailed talk about sharding and partitioning and Elastic Clusters. By the way, Elastic Clusters is based on Citus. Citus is an extension. It's an open source extension which is used to manage the distribution of data and querying of the data using its own queries, right? So Claire's talk tomorrow is going to happen, and she's going to delve deep into the concept of sharding, partitioning, and if you really want to go into the details as to how Elastic clusters work, you do not want to miss that out. Okay. And here is a simple provisioning, right? Like, okay, people often get confused. Okay, is it a new service altogether or is it the same? So it's like we are offering one thing called flexible server. In that, you get an option to have either a single node or a multiple node. So if you look here, you have cluster options, and you can pick an Elastic cluster and you can define how many nodes that you want. And as I said, each and every node is going to be unique, and it's going to have the same kind of SKU, same kind of disk, along with the HA options. Okay, and then you can basically pick your options, save, and create it. So you'll be having one endpoint managing multiple machines. There you go. So the deployment is completed, and you now have this cluster based on a particular sharding and an endpoint. Very simple to use. All right. So any questions so far before I move on to the next one?
Is Azure database for PostgreSQL and flexible server same or different?
It's the same. It's the same. So database for PostgreSQL is the name, and our particular offering is called flexible server. That will be the only offering that, at least, there's no difference. Any other?
Security can be set up across the region?
Oh, HA across regions? No, that's not possible, because the latency will be too high for us to do some synchronous replication for that. So I think it's any other questions? Okay, I'll move on to the next one. In terms of security, we're going to talk about one of the offering that is kind of unique. So many customers, particularly in financial sectors, right, they have some regulatory requirements in terms of credential management. Like, hey, I want to move away from password-based authentication, right? I don't want my password to be compromised, putting my entire data at stake. So is there a way for me to authenticate in a more sophisticated mechanism? And our answer to that is like Entra ID authentication. So what is Entra ID? It's like a cloud-based identity that links all the Microsoft services together, right? So before it used to be called as Azure Active Directory, but now it's I think it's renamed to Microsoft Entra ID. And basically what we are saying is you have an account, enterprise account, and it's a managed authentication service. So we can give you access token, and that time to live for the access token is kind of defined at different tenant levels, like how long should my access token be valid, all those things. And you can actually use that access token to log into your PostgreSQL database as a role. And once you're logged in, you can basically, you're just another role, right? Like you can create objects, you can own objects, you can grant permissions, revoke permissions, and whatnot. Let me couple this up with a simple demo as to how you can get started with this. So I'm in my flexible server, and I scroll down and I can go to the authentication tab here. And here it supports both password-based and Entra ID. And I'm just trying to add my Entra ID, which is Shriram at Microsoft.com, as a role in this server, and I just click on submit. Okay, now what I'm going to do is I'm going to log in my enterprise ID, great. And now I call this endpoint to get a particular token. Okay, and your token should be something like this. Yeah, like it will be like access token, and you have like a big string. And all I'm going to do is I'm just going to copy and paste it, and I'm going to simply try to connect to PostgreSQL. And if you look at my username, it's actually my enter ID, right? Shriram@microsoft.com, and I'm just going to paste the token, and boom, I'm able to log into my server. And if I do du, like which is like list all the roles, like you can see my enter ID as a part of a role inside Flexible Server. And then with that login, I can just I can run any queries. A very simple way to make sure you can use your enterprise ID, log in, and then run any queries as you want. Of course, it's not necessary that you need to be an admin to use this feature. You can also create non-admins users with enter IDs as well.
How we can disable the existing enter ID for that particular instance?
How we can? Sorry?
Disable.
Yeah, it's possible. Like you can just use Postgres password-based authentication. It's still that is an option that you can use. Yep. Right. So the next one is customer managed keys. By the way, like Microsoft uses service managed keys to encrypt all the data. So by default, we do encrypt the disk with a service managed key, but you may have compliance requirements that say, hey, you need to manage your own key for an encryption, meaning you bring your own key and you want to encrypt the data using that particular key. And if you're doing that, no one, including Microsoft, can access that data apart from you. Okay, and these keys are typically stored in Azure Key Vault. So that's another like a hardware security mechanism where you first need to authenticate with Azure Key Vault, get your key, and then use your key to actually encrypt the disk. Okay, so there is clear separation of duties between key management and data management, and this will help you with all your compliance requirements if you have it. And finally, like we are going to talk about like, okay, private endpoints. So if you're deploying a flexible server, you might be having a requirement saying that I don't want my data to be exposed to public IP. So what are the options that you have for me to deploy my Flex server in private access mode? So we do support two options for that. One is through directly injecting your flexible server inside a particular VNet and subnet. And by doing that, you're cut off from all the public IPs. No public IP can connect to your machine in that way. And also by doing that, you can define your own network security groups, which is going to be an ACL or an access control, like what connections can come in, what connections can go out from the subnet. You have complete fine-grained control. And the other way is to use a private endpoint. And private endpoint, you can think of nothing but like a network interface card that you generate, and which is going to have a private IP, and we are going to attach it to your flexible server resource. And all the connections that needs to come has to go through this particular private IP. Okay, so by doing this, your data and your connections will still be inside the Azure backbone network, which is going to be super fast, and there is no chance for data exfiltration here. Okay, so these are the private access options that you have if you want to deploy your server within a private link network. And I will take a pause there. I think we are now covered two important pillars, scalability and security. Any questions before I move on to the final topic?
A private link can give us access to the database?
Yes. You can basically connect to that server which is running your database through that private IP. To what?
Private endpoint we create for the
Yes.
storage account.
Yep.
Similarly.
Yes. Any other questions? Any questions? Okay. All right. Like the final thing or the final pillar that I want to cover is about AI ready database, how we are making Flex server ready. By the way, how many of you attended yesterday's training? Like, okay, it's quite a few. So there might be some repetitive part because most of the things were also covered yesterday during the training. But I think it might be good to explain the fundamentals for people who are kind of new and listening to the talk for the first time. So we are trying to make sure that flexible server in Azure is ready in terms of AI capabilities and how you can build applications on top of it at ease. Okay. Now, if you look at the foundational blocks that we have, the first major thing is for us to understand what is called as a vector. So what is a vector? Vector is nothing but a representation of an object, right? This object can be a text, it can be an audio, it can be a video, it can be whatnot. So we first need to understand this vector as a data type. And how is Postgres solving that particular problem in Flex Server? We do support a particular extension called PGVector. And this is an extremely popular open source extension. And by installing that extension, you will make sure that your database understands that data type called vector. So we have solved one part of the problem, okay, which is understanding the foundational piece, which is vector. Now the next problem is like, okay, who is going to give me the embedding for that particular thing, right? Like who is going to give me the vector representation of an object? So in our case, like we have an Azure OpenAI endpoint, and that endpoint is actually going to take in a text as a query, and it's going to do some computation. It's going to return a vector representation of that object. Okay. So now we have solved the other piece, like which is Azure OpenAI endpoint, PG vector is there. Now how do you integrate these two? And for that, like we have come up with like a very simple integration, again exposed through an extension called Azure AI extension. So think of it as like a gateway that sits between your Flex server and you pass your data, and in that extension, like you're going to configure like what is going to be the endpoint, what is going to be the key that you're going to authenticate yourself against, and then it passes that data to the endpoint, and the endpoint kind of understands it, authenticates it, and sends back the response, which you can go and store it back to your database. Okay. So now, yeah, we are also trying to come up with like a copilot specifically for flexible server. That's a work in progress, and we'll table it for another talk in the future. Okay, now let's look at this particular diagram here. So we have an application that's trying to talk or trying to perform a search operation on your Flex server, and the search is actually we are trying to make it more meaningful by doing what is called a semantic search or a context-based search, right? So here is a simple query that's actually coming from your application, which is like, hey, give me all the relevant results for the query which is databases with vector support. Okay, that's the user query that's getting passed from the application, right? And if you look at the query here, which is marked in that pink box, so the first step in order to achieve this is to first identify columns in your database that has text representation for which you can actually get an embedding or a vector format, right? You first need to identify that columns, go one row by another, pass those particular text to the endpoint using the Azure AI extension, get that embedding and store it in a different column altogether, right? And if you go here, if you look at the query, there is one like select star from table, order by, and there is a clause which is database description, there is a symbol, and then there is like another part on the right side of the symbol, right? And if you look at the right side of that particular symbol, like it's basically calling that OpenAI endpoint with the create embedding functionality, and it's passing like what is the model that I'm using and what is the user query that's actually coming, right? So this will actually result into a particular vector. And what we are doing is, with that vector that we got for the user query, we are now comparing or doing a mathematical calculation with all the existing vectors for each and every row, and then we figure out what is the closest match vector, right? And then we return that result to the user. And the symbol that you see is actually called the Euclidean distance, right? So it actually calculates the distance between two vectors, and the smaller the distance, the more closer the two vectors are, which means more meaningful the results are going to be. Okay, so now I just introduced a new data type. Then the next follow-up question would be like, how can I build or how can I use indexes on top of that data type? What are the options that I have? And let's look at like the two options, which is like the IVF flat and HNSW. These are the most popular open source vector indexes today. And think of IVF flat like you define multiple clusters and kind of like put a vector into one of the clusters, right? And you kind of have to fine tune it or kind of play around with the vector, with the some of the parameters like number of clusters in order to get a highly accurate answer, right? And when you compare that with HNSW, HNSW has like multi-layered graphs imposed on one another with connections in between, and because of this graphical structure, it's able to answer queries with more accuracy. Like the accuracy is always maintained. But the problem with HNSW is as and when new data is getting added to the table on which your vector is, it's going to be extremely costly to compute and rebuild this particular graph. Right? So in essence, what we are saying is IVF flat does a good work when there are larger data sets with low dimensionality, but HNSW, it does a good work with smaller data sets with high dimensionality. Now, what is our answer for large data sets with high dimensionality? And we are introducing a new vector called new index called disk-ANN vector index. And this was originally like formed at Microsoft Labs, research labs. And this is like turned out to be with our many benchmarking exercise much more performant, scalable, and accurate. And I'll just tell you like a quick summary as to how this actually achieves it. So it also builds a similar graph kind of structure and kind of stores the entire graph in the disks. Okay, and then what it does is like it has this compression and quantization technique where it's going to create a smaller version of that entire graph in such a way that it's big enough to be loaded into the memory. And with that compressed version of the graph, it's going to return answers based on the queries that it's coming. Okay, so the accuracy is retained superior when compared to IVF flat and HNSW. And currently this is available in flexible server, and it's also exposed through a particular extension called PG disk-ANN. And here is a quick code sample where you can just how to use this PG disk-ANN, how to get started, right? So you have a create extension and you create a table with an embedding column, and then you actually create an index on the table using disk-ANN, and that is it uses the embedding column. And it also, we can also define the functionality, like what mathematical formula should I use when I'm trying to do this, and cosine similarity happens to be one of the mathematical formula. And bottom part is like a simple Python application which tries to connect to your server, and it tries to execute a query. Okay, so now we talked about the foundational pieces, then we talked about like what is the vector indexing that we have. And then there is this concept called RAG. RAG is like retrieval augmented generation. Like if you look at this graph right now, we are already doing 1, 2, which is basically identifying the text columns, trying to get that embedding, storing in the database. 3, 4, 5, 6 is also we just did with vector search, right? We got the user query, got its embedding, checked what are the relevant indexes using the mathematical formula, and then we return the top ones. Okay. Now what we are doing with RAG is something that we create another custom template, and we are telling the model, hey, you are trained with a pre-trained data, but here is the user query and here is the relevant docs that we found to be most relevant to the user query. Now generate a prompt based on that. Right. And this exactly is what happens here, and I've built a very simple Python application using LangChain framework. I'm not sure how many people are familiar with that, but this is a great framework for you to work with LLMs. And here we are building a semantic search RAG app with just a few lines of code, and I'm just going to walk you through that very quickly. So in the first phase, we are just defining connections to flexible server, what is the model that we are using, and then we define a user defined function which is actually going to take a user query, and then it tries to retrieve the top relevant results, right? And if we look at the implementation of this function, it calls the embedding model to get the query, it does some string parsing, and then it kind of connects to your database and then retrieves the top results. Pretty simple, right? And here is the interesting part. Now I'm going to define a composite prompt template, and it's going to take in 2 variables, which is context and question. And there is a template which I just defined saying that, hey, you're an AI assistant, use the following retrieve context to answer the questions, and here are the 2 variables, context and user question. And with LangChain framework, you have the QA chain thing where you just need to create an object populated with some arguments, and then basically it's going to call the custom template on behalf of you. And finally, we are putting it all into action. So here is the query, how does Postgres handle vector search? It's going to call the function that we defined in the second step to retrieve the relevant docs, and then we do some string parsing. We do some string parsing to make sure that we can pass this string data into the composite prompt, and then we call the QA chain run with the context and the question. And it's going to come back with the most relevant answers, and we display it. Now imagine how simple this is. Like to do something as complex as semantic search, it's now been made very easy with the existing frameworks and with models out there and closely integrating the models with flexible server. It can be done in probably less than a week's time. You can build something as complex as doing a semantic search. That's how easy it has become now, and we plan to make it even more simpler. And finally, where is it all heading towards, right? So we started with vector search, we moved on to RAG, and we are also moving to advanced RAG concepts where we have seen that the accuracy of the results that are getting returned by these concepts are even more better in terms of accuracy. And one of such model is called the semantic ranker. And semantic ranker, you can think of like it's going to take in 2 queries as the input, and then it's going to give you a relevance score between 0 to 1. Now how does that work, right? It's going to not just go token by token, but rather goes in a step deep and try to understand what is a semantic. Is it a positive statement? Is it like a positive thing or neutral or negative? It tries to use those semantic scores and does some mathematical calculation to get back to you with a relevance score between 0 to 1. Again, it's hard to explain the details of that, but if you're really interested to know more about how semantic ranker model is, you can go and read the blog post there, and you also have the GitHub repo which has its implementation. I'll just keep the slide open here for now. And we have built a solution accelerator for this one. So this model is residing in Azure ML, and by just deploying or executing the solution accelerator, which is nothing but a script, you actually get an endpoint for you to connect to it, and it also comes up with a stored procedure that you can use in your PostgreSQL query to actually use that to call that endpoint and get the results. Okay, so that is semantic ranker. And finally, graph RAG, right? So far we have made PostgreSQL a relational data store. We also made it like a vector data store, and now with graph RAG we are making it a graph data store. And how are we able to achieve it? It's through Apache Age extension. So you can build a graph using this extension. You can create nodes, define relations, and then you can also create a summary of the graph. And then with the summary, you can actually start using graph queries using Cypher. And what we have seen so far is the accuracy of graph RAG exceeds all the other RAG concepts that we have seen so far. Again, if you want to dive deep into how graph RAG, how the Apache Age extension is implemented, I would point you to these links. It also has the code repo as well. So typically what we have seen so far, it's like a combination of all these advanced RAG rather than having them as standalone has led to a better accuracy. And probably like we'll be heading in the direction, like if there is another new advanced RAG concept comes in, like summarization, we might want to expose that in flexible server through having all these solution accelerators as well. Now with that, I think I've come to the end of the talk. One thing that I want to point out is like, here's a quick snapshot of resources for you to get started on flexible server if you're not used it. I would pause a minute there for you to take a picture of that. And also give us a follow on LinkedIn. And then like we also have booth socks. Please come and visit the booth, say hi. I think most of you have already done it, but in case if you're not, I would encourage you to come and we'd love to talk to you about this as well.
Before we run out.
Yeah, before we run out of the socks. And then we have the POSET event. So Claire here, so she is the chair of that event. She has been conducting she's now in the 4th year. And like we had that, it's a completely virtual event and it's currently happening between June 10th and 12th. And I would encourage you all to make sure that you participate in that event. And yeah, thank you. And I'll take any questions.
We will not expect you to be upgrading a production instance, and you will always be upgrading some sort of a lower UAT instance and then doing your testing and then doing it. So that's the logical part. As an infrastructure provider, what we take care is that when we do an in-place major version upgrade, which is a feature, then we do a lot of internal checks and we make sure your database is coming up online from a technical standpoint. And if there is any issue, then we automatically, like we internally downgrade, like because we take snapshots and all those things. So yeah, like do the testing and we'll trust you to do. You have done your testing and due diligence.
Oh, yesterday.
Anybody question? I can pass on the mic.